Water management in cashew. Cashew is one of the important foreign exchange earning crops and it is traditionally grown in the coastal region in India. Cashew is generally grown as a rain-fed crop mainly along the coastal areas in low fertile soil. Majority of cashew orchards in India are not irrigated. In India, the vegetative development of cashew occurs during rainy season and the reproductive phase during the dry season. Although cashew is grown in high rainfall environment, it experiences severe moisture stress during January to May with the highest water deficit during March to May. The critical growth phases such as flushing, flowering and nut formation in cashew also occur during these dry periods. Any form of biotic and abiotic stress during these periods adversely affects the flowering and fruit set and results in premature nut drop and finally reduces the yield and productivity of cashew. Lack of moisture availability during fruiting season is one of the several factors associated with the low yield in cashew. Studies have shown that supplemental irrigation can significantly improve the productivity and yield of cashew. In hilly areas with no access to irrigation water, the water deficit to the crop can be managed to some extent by the adoption of region-specific soil and water conservation practices. Adoption of such practices is part of cashew production technology in case of sloppy areas to prevent surface runoff and soil erosion. Different technologies are available for in situ soil and water conservation in cashew. The adoption of these practices should be done in accordance with the local conditions, topography, water holding capacity, and infiltration characteristics of the soil. In continuous contour trench, these trenches are taken in sloppy areas, that is with 7 to 8% slope, running through entire field length along the contour. The trench dimensions recommended is 0.5 meter by 0.6 meter. Modified crescent bund consists of a crescent-shaped bund of 6 meter length, 1 meter width and 0.5 meter height at 2 meter radius, which is taken at upstream of the cashew terrace to retain water as well as litter. In staggered trench, the size of trenches is 5 meter length, 1 meter width and 0.5 meter depth, and it has to be taken between two rows of cashew or in the middle of 4 plants across the slope. In reverse terraces, the recommended dimensions are 2 meter length, 2 meter width and 0.7 meter depth, which are constructed so as to be inclined from periphery to the center. The recommended dimensions for catch pits are 3 meter length, 0.5 meter width and 0.5 meter depth, which are constructed upstream of cashew planted terrace to catch and retain the runoff and to increase percolation. Adoption of coconut husk burial techniques with soil and water conservation techniques like modified crescent bund, staggered trenches, etc. improve the water retention in soil for longer periods. Bigger pits and mulching can also be followed during the establishment of cashew plantations. Pits of 1 meter cube size are to be dug open at recommended spacing following other soil and water conservation measures such as terracing. These pits are to be filled with topsoil, organic manure and rock phosphate at recommended rate up to 2/3 depth. The graft can be planted at center of this pit and proper mulching needs to be done. Trenches with vegetative barriers. Inclusion of vegetative barrier along with continuous contour trenches and staggered trenches in reversely sloppy areas can substantially reduce runoff and soil loss. Styloxanthus meta, Vetiveria zygenoids are some of the recommended vegetative barriers. Apart from helping to reduce runoff and soil loss, the vegetative barriers can be harvested to provide additional income. Green manuring and mulching with crops like glyphosate at vacant spaces and borders provide material for mulching. Mulching the tree basin with green mulch helps to conserve the soil moisture. Circular trench with leaf litter and coconut husk. This practice is generally recommended for East Coast areas wherein coconut husk and leaf litter are buried in circular trenches of 0.3 meter width and 0.5 meter depth, opened at 2 meter away from the cashew trunk. Supplementary or protective irrigation. Plant the cashew grafts along monsoon season to The grafts need to be watered once in every 3 to 7 days. Once established due to the deep taproot system, the cashew trees can survive the moderate dry season without irrigation but with adverse effect on yield. Cashew is known for its drought hardiness and generally grown as unirrigated. However, the yield can be increased if irrigated. Providing irrigation at 200 liters per tree at 15 days interval during November to March increase the nut retention and yield. For yielding trees, protective irrigation is to be given only after the plant enters flowering phase during nut set and nut development stages. By providing black polythene mulch, the quantity of irrigation to be provided can be reduced to 60 liters per tree once in fortnight. Drip irrigation. In drip system of irrigation, water is applied through a network of pipelines and applied to the root zone of crop drop by use of emitters or drippers. In this system, water is applied based on ET demand of the crop and root zone is always maintained at field capacity levels. Drip irrigation allows water saving to the tune of 40 to 70% in comparison to other methods of irrigation and 25 to 80% increase in yield. The water requirement in cashew is decided based on the climatic condition, canopy area and growth phase of the plant. Fertigation. It is a technique of applying plant nutrients by dissolving them in irrigation water, mainly through drip system. It helps to deliver the correct quantity of water and nutrients to plant roots zone. Fertigation ensures almost 90% use efficiency for the applied fertilizers as it enables applying the nutrients at the most nutrient demanding stage of crop at right place and right time. The right combination of water and nutrients is to be used to obtain desired results through fertigation. Under the actual field conditions, the number of drippers, flow rate, availability of labor to run the system daily, age of the cashew trees, its development stages, etc. vary widely and user need to customize his or her requirement. Similarly, in designing fertigation schedule, the field conditions vary widely under each farmer's field. The availability of fertilizer, soil conditions, density of planting, age of the tree, etc. needs to be taken into consideration while formulating a fertigation schedule. To empower the users to do drip or fertigation calculations and scheduling at their convenience by inputting their specific needs and resources, a software and mobile app is developed by ICAR-Directorate of Cashew Research, Puttur.